Hello friends, I welcome you to my YouTube channel MacPM. So this is our second video based on the numerical problems of fluid mechanics. So this is our topic today, Newton's law of viscosity. So we have two problems based on this topic. We will solve these two problems in this video. So let's try the first one. So the problem given is a plate 0.025 mm distance from the fixed plate. So here it is given, here it is a fixed plate and there is another plate. Here distance is given as 0.025 mm from fixed plate, moves at 60 meter per second. So speed of this plate is 60 centimeter per second and requires a force of 2 Newton per unit area. So F is equal to 2 Newton per unit area. Suppose area in meter square. This is also given Newton per meter square. So you know that force per unit area is called stress. If it was only F is equal to 2 Newton, then it would be force, but it is per unit square area, then it will become stress, because stress is equal to force upon area. Okay, so now this plate is sliding over this upper plate is sliding over lower plate, so there will be shear stress tau between these two plates. And from Newton's law of viscosity, we know that tau is equal to mu du upon dy. Here tau is shear stress. Tau is equal to shear stress, the stress which is stopping this plate from moving, it is shear stress. And du is equal to change in velocity, and dy is equal to change in distance. So from this question, if we first of all we have to convert these units in standard units. The velocity is given as u is given as 60 centimeter per second. If it convert it into meter per second, then it will be 60 divided by 100 meter per second, because we all know that 1 meter is equal to 100 centimeter. So it will become 0.6 meter per second. And second thing is distance between these two places. Y is given as 0.025 mm. If we convert it into meter, then we know that 1 meter is equal to 1000 mm. So it will become 0.025 divided by 1000 or into 10 to the power minus 3 meter. Now force per unit area is given, which is stress. So tau will become 2 Newton per meter square. So we'll put all the values in this equation. So we'll put tau is equal to 2 is equal to mu is viscosity, which we have to find, and change in velocity. Initial velocity of this plate was 0 and now it is moving with 0.6 meter per second speed. So it will become 0.6 minus 0 divided by change in distance is 0.025, which is equal to 0.025 into 10 to the power minus 3. Okay, so if we calculate all, this mu will become this, it will go this side and this will come down. So it will become 2 into 0.025 into 10 to the power minus 3 divided by 0.6. If you will calculate this, then you will get 8.33 into 10 to the power minus 5 Newton second per meter square. Okay, this is the unit of viscosity. if you want to convert it into poise with the unit of viscosity also, so you know that 1 poise is equal to 1 by 10 Newton second per meter square. So if you want to calculate the viscosity in poise, then you will get 8.33 into 10 to the power minus 5 into 10. So we'll get 8.33 into 10 to the power minus 4 OS. So this is the viscosity. You can write this or this, but only the difference is in the units. Okay, now we will move to the second problem. The second problem is a flat plate of area 1.5 into 10 power minus 6 mm square is pulled with the speed of point related to the another plate. So there are two plates. This is one plate, this is another plate. Suppose this is fixed one and this one is moving. So area of this plate A is equal to given as 1.5 into 10 to the power 6 mm square. So we know that we have to convert everything in meter, so it will become 1.5 into 10 to the power 6 mm square divided by 1000 into 1000 meter square, because 1 meter is equal to 1000 mm. So it will become 1.5 meter square. What is this? So area will become 1.5 meter square, and is pulled with a speed of 0.4. Speed is already given, u is 0.4 meter per second. So this is in standard unit. Related to another plate, located distance. The distance between these two plates is 0.15 mm. So distance y is equal to 0.15 mm, which will be equal to 0.15 divided by 1000 meter. So it will be equal to 0.15 into 10 to the power minus 3 meter. So this is the distance between two plates. Okay. Find the force and power required to maintain the speed if the fluid separating the viscosity is given as 1 poise. So now we have to find the force and power. So we will find force first, then we will find power, and we know that power is equal to force into speed. So once we find the force, then we will multiply the speed of this plate, which is u, with force, then we will find power. Okay. Now this is the 1 poise, which will be equal to 1 by 10 Newton second per meter square. Now we know that Newton's law is tau is equal to mu du upon dy. So here mu is 1 by 10 into du is change in velocity is 0.4 meter per second divided by dy is distance is 1.15 into 10 to the power minus 3 meter, and this one is Newton second per meter square. So now we will find, if we multiply and divide all this, then we find 266.66 Newton per meter square. So this is shear stress between these two plates. Now we have to find the force. Now force is equal to stress, shear stress into area, because shear stress is equal to force divided by area, so force will be equal to shear stress into area. Now area of the plate we have already calculated is 1.5 meter square, so it will be force divided by area, so force is equal to stress into area, which is equal to 266.66 into area is 1.5. If you multiply these two, then you will get 400 Newton. Okay, so this is the force required to move this plate with the velocity of 0.4 meter second at a distance of 0.15 mm. Now we have to find the power. What is the power required? So power is equal to force into velocity in direction of force, so it will be equal to 400 into velocity is, we have already calculated the velocity 0.4 meter per second, so it will be 0.4, so it will be 160, and the unit of power is watt. So this will be our answer. So this is our second answer and this is our first answer. So I hope you understood up to here. If you have any problem, then please ask in the comment section. Thanks for watching this video.